In this video, I will be reviewing the MD-80 cockpit experience at the C.R. Smith Museum. This exhibit was very busy when I was attempting to record all this. So the first time I got through a few of the button pushes with the guide, and then I had to come back and do it again, and then another group was pressuring me to get out of the cockpit, which was kind of lame of them to do, but anyways, thought I would share this. MD-80 is one of my favorite aircraft, and I think it's pretty neat that they have this preserved at the museum for everybody to see.
Works and some of the features of the MD-80. Each time you press the button on the center console, a special feature of the cockpit will be highlighted. So, push the button and we'll get started. The flap handle allowed us to increase the surface area of the wing by selecting flaps for takeoff and landing. In fact, unique to the MD-80, we could even fine-tune this more using a dial just below it, giving us a way to fine-tune the flap setting, say to 17, for example. Hello, I'm Captain Kent Ween. I used to fly the MD-80 out of New York, and in fact, I flew this particular airplane from Chicago to Fort Lauderdale and then on to Dallas-Fort Worth. Today I'd like to just point out a few of the quirks and some of the features of the MD-80. Each time you press the button on the center console, a special feature of the cockpit will be highlighted. So, push the button and we'll get started. Unique to the MD-80 was a mechanical pin that popped up, indicating when the nose wheel was down and locked. So the airplane had a feature that was kind of unique. It's called the perf button. When you push the perf button, instead of the throttles advancing and declining to maintain speed at level flight, the airplane was allowed to climb and descend ever so slightly. The only problem with this is that you might be 200 feet higher or 200 feet lower than your assigned altitude. If you look in front of you, you'll have the yoke, which is essentially a steering wheel for the airplane, like in your car. Turning it to the left rolls the airplane to the left, turning it to the right rolls it to the right. If you pull back, the airplane climbs, and if you push forward, the airplane descends. We would generally use the autopilot for most of the flight. However, for takeoff and climb out, we would hand fly the airplane, and also for the approach and landing. So when we're not hand flying the airplane, we use the autopilot. And to control the autopilot, we use these three knobs to control speed, heading, and altitude. The MD-80 had three different fuel tanks depicted here. The left and the right main, which were in the wings, and the center tank in the fuselage. Once the aircraft was fueled, the total fuel is depicted just below that, and the gross weight showed up at the bottom, showing how much the aircraft weighed. On the front side of the throttles are the reverse thrust levers. One unique quirk to the MD-80 was, at the gate, we were allowed to lift those reverse thrust levers, which redirected the air from the engines forward, allowing us to power back from the gate without using a tug. It was a noisy and dusty process that lasted only a few years. While the overhead panel may look a little bit complicated, it's actually divided into separate systems. Starting at the top, we had the electrical system, followed by the fuel system, air conditioning, and pressurization. At the very bottom were annunciator lights. So if any problem happened, these lights would light up indicating what the problem was. Note that each switch was a little bit different from the others. This was to prevent you from selecting the wrong switch. The flap handle allowed us to increase the surface area of the wing by selecting flaps for takeoff and landing. In fact, unique to the MD-80, we could even fine-tune this more using a dial just below it, giving us a way to fine-tune the flap setting, say to 17, for example. The co-pilot sat in the right seat, and next to their left foot is a red door. That's the alternate gear extension, which, ironically, is the normal method a DC-3 used to lower its gear. It's a bit of a throwback to an airplane they built many years earlier. To align your seat properly, there were two sight gauges, one for the co-pilot and one for the captain. When you look down the sight gauge and it's lined up, you'll know that your seat is adjusted properly for flying.
This is a big old jump seat here.
Look above your head. actually had a sunroof, which gave us more visibility. However, on hot days and when it was too bright out, we often found we had to cover it up with anything we had in the cockpit.
That's a lot of controls in here, huh?
This is the nav display. It shows our route, which is made up of a series of waypoints. It also showed what time we would arrive at each waypoint. This is the speed brake lever. By squeezing and pulling it back, we would extend some panels on top of the wing, which slowed the aircraft. If you look down where your feet are, that's the rudder pedals. Not only do they move the rudder left when you push left, right when you push right, but at the top of the rudder pedals, when you pushed, it would activate the brakes, which would slow us down on the ground and keep us from taxiing too fast. In order to know how fast we're traveling, we have an airspeed indicator, which are displayed in knots. A knot is essentially 15% more than a mile per hour. Just on the ring of the airspeed indicator, we have some plastic tabs. Those are called bugs. And we'd set these bugs at different speeds in order to tell us when to rotate the aircraft, when we lift off, and, on landing, at what point to put out various sets of flaps. On the yoke is a chart holder that would hold charts like a taxi diagram or an approach chart. See the mirror on top of the glare shield? That's actually there for the pilots to check the compass. It's almost like they forgot to put the compass in the airplane and the only good spot was behind the co-pilot's head. Well, that's not really the case. It was put there to avoid electromagnetic interference. This is the mechanical checklist. It's something that was unique to American Airlines. Before takeoff or before landing, we could actually check off items out of sequence by flipping these switches.
Let's go itinerary plan.
Yeah.
This is the manual pressurization control knob. In flight, in automatic mode, this knob would move back and forth, controlling the outflow valve, which controlled the pressurization of the aircraft. In an emergency, we could manually control this knob, opening and closing the outflow valve to depressurize the aircraft. These are the throttles, essentially a gas pedal for your airplane. Moving the throttles forward increases the thrust, and moving them back decreases the thrust. Look above the windows. Notice the track? One of my favorite features of the MD-80 was that you could take the window shades and slide them on this track all the way around the cockpit. So, you can put it exactly where the sun was, since the sun wasn't just always straight in front of you. In the event of an engine fire, the fire handles would illuminate. After pulling the fire handle, the fuel system, hydraulic system, and pneumatic system would shut off. The primary flight display gives us a digital readout of the airspeed indicator and the altimeter, along with an artificial horizon, which allowed us to fly in the clouds.
I got ahead of myself, okay?
The MD-80 had two radios. The left one was typically used to talk to air traffic control, while the right one was used to talk to American Airlines operations. In order to see how high we are, we have an altimeter, which displays in feet above the ground. So, if we're flying at flight level 320, it would read 32,000 feet. These are the landing light switches. They would extend the landing lights out of the wingtips, which, through its primary function, lit up the runway, and secondarily, gave us a little bit of extra drag to help us slow down.